Hey everybody, welcome to exercise 9.29, which is number 9 on the chapter 9 homework assignment. And so I've already downloaded the data file. And so we'll just get started on the municipal website. The city of Tulsa states that the rate it charges per 5 CCF of residential water is $21.62. How do the residential water rates of other U.S. public utilities compare to Tulsa's rate? The file residential water, so that's right there, contains the rate of per 5 CCF of residential water for 42 randomly selected US cities. So click on the data file to get the file. So when you do that, it brings up this Excel file for you. And then it wants you to formulate a hypothesis that can be used to determine whether the population mean rate per 5 CCF of residential water charged by US public utilities differs from the $21.62 rate charged by Tulsa. So first thing it wants us to do is choose our null hypothesis. So since we're asking differs, not is lower or higher, then we're going to do the whole null hypothesis is that it equals 2162. And the alternative hypothesis would be that it does not equal 2162. And then it wants the p-value for our hypothesis test. So let's just figure out what information we have given all this. So we can, with all of this data that's given to us, we can definitely, well, let's just start with what it gives us. We have the null given to us, or the assumed hypothesis, or the hypothesized mean is $21.62. We also have an n, so a sample size of 42. Those are both given to us right there. And then with all this data, we can figure out a mean and a sample standard deviation. So I can find the mean just by hitting equals average. And the sample standard deviation we're doing equals S T DEV dot S. All right, so we've got all of that information. And so it wants us to find the p-value, which is the probability of getting a mean of 2024 based on all of this other information. Okay, so to do that, the first thing we'll have to do is find a test statistic. So to find the test statistic, we'll just use the formula, which is the mean minus the null, or the hypothesized mean, divided by the standard deviation over the square root of n. So there's our test statistic. That means our mean of 2024 falls 1.14 standard deviations below the hypothesized mean of $21.62. So now that we have all that information, we can figure out our p-value. So our p-value is just, remember, we don't have a population standard deviation. We have a sample standard deviation. So we're not going to use the normal distribution. We're going to use the t distribution. So I'm going to say this equals t dot dist and then our test statistic is x, and our degrees of freedom is n minus 1, and our cumulative is true. So what that returns to me is the probability of getting a t-score of negative 1.14 or less. Since this is a two-tailed test, to find out the probability of getting 1.14 or negative 1.14 or less, or positive 1.148 or greater, I would just take this amount times 2. Alternatively, I could have used t.dist.2t and put in that for the x value and then n-1 for my degrees of freedom. But if you do it this way, it doesn't like negative values for your test statistics. So you'll either have to do like the absolute value, or you could do it as a negative too. But you'll see that comes out to the same thing. So I think sometimes the 2t thing gets confusing. So I just use the t.dist and then I multiply it by 2 when I have a two-tailed test. You can do it however you want. So that's the amount right there that is our p-value. So that's 0.2576. So it says at an alpha of 0.05, oh, they're giving us another piece of info here. At an alpha of 0.05, can your null hypothesis be rejected? And so the rule here is we'll compare our p-value to our alpha. And if our p-value is greater than an alpha, so our p-value is 0.2576, that's quite a bit greater than 0.05. In essence, that means that the probability of us getting this test statistic is greater than the alpha. And if that's true, then we will not reject the null hypothesis. In other words, we will say that the mean rate per 5 CCF of residential water throughout the US does not differ significantly from the rate of per 5 CCF of residential water. In other words, even though our average or our number, right, our mean here came out less than our hypothesized mean, it's not enough less that we can conclude that these numbers are really statistically different given all this other information. Then it will say, repeat the preceding hypothesis test using the critical value approach. So we could find our critical value, which we'll do by doing equals, and then t.inv of the alpha divided by 2. And then our degrees of freedom. Whoops, sorry. We'll do alpha divided by 2, comma, and then our degrees of freedom, which is n-1. This will return a negative value, but because it's a two-tailed test, it's going to be plus or minus that amount. Alternatively, if we wanted to use the 2t, we could do t.inv.2t, and then put in the probability, or just put in the alpha. And by putting in 2t, it will divide it for us, comma, degrees of freedom as n-1. So, and that would return it as a positive. So we're going to say that this is, the critical values are plus or minus 2.02. Our t-value, our test statistic, we already figured out up here, which is a negative 1.148. So for the critical value approach, we'll just compare our t-value, which is negative 1.148, to our critical value of negative 2.02, and say 1.48 is closer to the mean than 2.02. And so we would not reject the null hypothesis. Again, same conclusion, which is even though that is less than the mean, it's not enough below the mean that we can conclude that the numbers are statistically different from each other. So we'll check our work. And there we go. Hopefully that's helpful to you. I know this has been a tough problem for several people, and I hope you have a terrific day.